outperform smelting. As of 2 months ago, now claim we are the fastest and most efficient metal recovery technology on the planet. We get over 99% recovery of metals in less than 15 minutes. And what's more, we do that at less than 50 degrees Celsius in terms of our operating temperatures.
Today I brought on Fred White, Chief Commercial Officer of a company called DEScycle. DEScycle focuses on smelter-free metal recycling, enabling e-waste recovery with low-temperature chemistry. It also decentralizes the infrastructure for metals recycling. Today we discuss how DEScycle is reinventing e-waste recycling and how they're different from smelting, as well as their breakthrough chemistry and performance and the decentralization of circular supply chains. This is Earth ABC featuring Fred White. I'm super stoked about this conversation, especially because it touches on the concept of circular economy. And your company, DEScycle, is very much about waste management and material innovation. And I bet there's much more to it than just that. So looking forward to learning more. Thanks for joining me, Fred.
Pleasure to be here, Sean. Thanks for having me.
And 2 weeks ago, I saw that you gave a talk in Munich to a full audience about the most overlooked infrastructure gap in the global economy. And I'd love to hear it from the man himself. So if you could you talk about what that overlooked infrastructure gap is?
Yeah, absolutely. So what's coming to the fore now is a lot of Western governments and nations are realizing that we need an industrial strategy. And critically, what's missing from that is how the industry is actually resourced. So critical metals is what I'm talking about. And at DEScycle, we sit right in the intersection of critical raw materials and circularity. So the talk in Munich last week was really around how can Europe in particular upgrade its quite dilapidated infrastructure in terms of how we both produce and recycle critical raw materials, and furthermore, how we use them in an EU economy. So it was a really interesting discussion. We had obviously ourselves there from a recycling standpoint, but we had, semiconductor manufacturers, EV manufacturers. It was a really, really interesting group.
And so there's a lot of electronic waste that's like in circulation and I guess also out of circulation then. And then so what is produced from this electronic waste?
Yeah, so electronic waste or e-waste is actually the world's fastest growing waste stream. We generate over $100 billion of metal value in e-waste every year, and that's actually going to grow to 120 billion by 2030. So in just 5 years' time.
Yeah, that's a fast growth.
Yeah, super fast, super fast. And if you think about it, everything depending on electrification, data center infrastructure, down to, how many iPhones and smartwatches do you have? It's all generating electronic waste at the end of the day. So this is a huge, huge resource. But the system for recycling electronic waste is just completely broken at the moment.
Yeah, I bet. And you use the word dilapidated, which I think is like spot on. And so diving into that a bit more, like what aspects of this like infrastructure gap is DEScycle filling by solving?
Yeah. So let me just hit you with some numbers to start off with. So
I love myself some numbers.
Of the $100 billion of critical raw materials we generate every year in e-waste, we actually only recycle around 20 billion of that. So around 80% is left as waste. Wow. And a big part of that is this recycling model is broken. And we believe a big part of the reason it's broken is it's reliant on an old, outdated technology. And that technology is smelting. Now, if you don't know much about smelting, it is a process which operates at over 1,000 degrees Celsius, burns electronic waste, plastics and all. But crucially, it's not often an e-waste recycling technology. It's actually a technology that's built for the mining industry. Now, what these smelters actually do is they take copper concentrate from the mining industry, so like mining ores effectively, and they blend that with e-waste in a 1:10 ratio, 10 being the copper concentrate. And then they burn everything at 1,000+ degrees, and then lots of other pretty horrible processes later, you'll have your recycled metals. Now, what that has led to is this huge, huge barrier to entry in the recycling industry. So it's split itself up into upstream recycling, which are all the companies doing the collection and disassembly of electronic waste. So think everyone from your friendly local recycling company up to bigger companies like Iron Mountain, Sims, Veolia. But it's a pretty fragmented market. And then you have this huge barrier to entry where metals are actually recycled. So the smelters, the downstream recyclers, if you will. And the reason there's a huge barrier to entry there is to build a smelter, they cost billions of dollars in infrastructure capex to actually install. They have huge energy demands, so are often located next to, you know, their own power plants, hydroelectric dams, things of those natures. And then they are actually pretty pollutive in terms of what's going on in the world, or in terms of how they're operating. So not just carbon emissions, but also metal particulates, which are both a human and environmental health hazard. For us, all of this combines to just say and scream, actually, smelting is not a future-facing technology.
Mm-hmm. Yeah, I can clearly see why. So correct me if I'm wrong, I presume that DEScycle is then a smelter replacement, hopefully.
Correct. That's exactly what we've built at DEScycle. We have designed a smelter replacement technology based off a completely new and novel class of chemistry. The chemistry itself is something called deep eutectic solvents, and it's actually a salt-based liquid. So just like someone has discovered acids for the first time, scientists here in the UK have discovered this deep eutectic solvent, or DES chemistry, and there's millions of possible formulations. They can do millions of different jobs. So what we've done is harness those millions of formulations, put them together in an actual technology flow sheet, and created a scalable, low temperature, clean way to recycle metals. But what's more, we outperform smelting. So I can, as of, I would say, two months ago, now claim we are the fastest and most efficient metal recovery technology on the planet. We get over 99% recovery of metals in less than 15 minutes. And what's more, we do that at less than 50 degrees Celsius in terms of our operating temperatures.
Those numbers are absolutely nuts.
Yeah.
How have you been able to like prove all of these numbers?
To be honest, we were quite surprised ourselves when we set out, you know, building this tech a couple of years ago. We said, okay, you know, in the labs, we were doing like 24-hour leach times, and we were like, commercially, maybe we'll get to 8 hours. And then a year ago, it's like, okay, maybe we'll get to 2 hours. And literally 2 months ago, we're like, well, we're at 15 minutes. We're like, okay, wow. So there's been a lot of work that's gone into the development of this technology. And we've actually been focusing on e-waste since 2021. And so for 4 years, e-waste has been our sole focus, and we've been plowing a lot of resources, a lot of very smart scientists. And I'll give our co-founder and CTO, Rob Harris, a special mention here, who's the inventor of our technology. But it's been a really exciting journey. And really what we've done with that is try to always simplify something that's extremely novel and create what we call a minimum viable process. So we've taken this like hyper novel chemistry where, simply put, metals behave and react differently, but we've tried to apply that on industry standard equipment. So we don't want to reinvent the wheel the whole way through the process flow sheet. So we've kept everything kind of the sexy science in the chemistry, and then everything else actually looks quite standard. So if you walked into a DEScycle facility, it would look much like a brewery or a microbrewery, than it would any kind of hyper specialized plant. But what's actually going on inside the chemistry is the secret sauce.
Yeah, I bet. Yeah, that 90% recovery in 15 minutes, again, absolutely nuts. You mentioned a couple of partners, or you mentioned the word partners. What do those look like at the moment?
Yeah, we've had great success in building traction and getting partners into the business. So, you know, going chronologically, if you will, we were selected in 2022 by the Amazon Sustainability Accelerator here in the UK, which has been a great kind of hotbed for growing us from a very early stage. We've also managed to get in an early adopter in a company called Gap Group. They are one of the UK's leading upstream recyclers, and they have basically validated the product market fit for us. We're definitely solving a real customer need, and they've identified that. So we formed a venture to launch our technology with them. And then on a kind of bigger scale, we've also got strategic investments from Cisco in the US and Mitsubishi in Japan. And it's really exciting for me personally now to get those bigger names and to get that kind of larger market traction of what we're doing here. I think that's quite a USP in the area of e-waste recycling. We're not the only company globally that's going after novel ways of, trying to replace smelters, but we are the only one with major strategic backing.
Gotcha. And so with there being a lot of these different players in like the e-waste management, what makes like DEScycle especially interesting in terms of making your technology different and then defensible?
Yeah, so it's all down to the technology. So firstly, what we're trying to do is not just replace an outdated system as we see it in smelting, which is known as pyrometallurgy, so fire and metal recovery, with the next thing. The next thing is actually hydrometallurgy, using water-based acids and solvents to dissolve and recover metals, and that's been going on for many hundreds of years in the mining industry as well. So a lot of other people are focusing on hydrometallurgical solutions to try and recover metals from electronic waste, but there's some big problems there that they need to overcome, and there's actually a litany of failures in the hydromet space over the past 25, 30 years. Tried to crack the smelting problem, but the problem with smelting is it's unspeakably horrible, but it's actually quite efficient and cheap once you've built the thing. So that's what you're competing against. So what we've got is something we refer to as ionometallurgy. It's something completely new and different based on these salt-based liquids. So a couple of the key technology differentiators, I've mentioned the performance, which is a complete standout, but it's actually the way in which the chemistry itself works. So in a standard acid-based process, your chemicals are consumed when you dissolve and recover the acids, or the metals, sorry. Where in our process, our DES chemistry is actually just the medium of dissolution, and we use something known as an electrocatalyst in the formulation, which acts almost like a reverse battery. So what it does is it steals electrons from metal ions in the liquid, making them dissolve. And then what we do is we use this reverse battery and drain off the electrons that's absorbed, and then just loop it back around and the DES background in a closed loop system. So rather than having to neutralize or regenerate or dispose of large quantities of chemicals, we're not doing that. So combined with the low energy, the scalability, and the performance, it leads to a very low cost process. So that's really where we're different in terms of the tech. And that's where we're getting the traction with the likes of Mitsubishi and Cisco. In terms of defensibility, we've got a granted patent over the technology, which the company owns itself 100%. So we're not reliant on any technology licensing coming from anywhere, apart from the original invention of the chemistry. Again, special mention to the University of Leicester. But the technology we're actually commercializing was invented at DEScycle by our CTO, Dr. Rob Harris. Beyond that, there's the 20 years of experience Rob and his team have racked up at the university, which creates quite a steep moat, or a deep moat, I should say, around what we're doing in DES. Now, there's millions of different possible DES formulations, and there's lots of different ways you can actually use and apply these chemicals and chemistries to treat and recover metals. And knowing which combinations of chemistries to use in what way is really quite a deep moat. What we're seeing out there with other largely academic institutions looking at DES chemistry is they're making the same mistakes Rob made 20 years ago. So there's quite a steep or big first mover advantage for us in the field of chemistry.
For sure. What a comprehensive answer to making your technology different and defensible. I think that really deep moat is something that puts you guys really ahead. And you guys are for sure putting the deep in deep tech. And so you guys are pretty much kicking out like these high energy pollutive smelters, these toxic chemicals, and these strong acids in the metal industry. And those are all great benefits, but in terms of keeping the company afloat and then profitable for years to come, what's like the business model, and how exactly do you guys make the money?
Yeah, absolutely. So again, stepping back to what happens today, we have the upstream recycling market who collect and disassemble e-waste, and they sell the valuable components, so things like printed circuit boards, server boards, memory, CPUs, GPUs, whatever it might be, to the smelters. So all of that value is captured by the smelters, and they don't really pay very good rates to the upstream recycling community. So what we're doing is fundamentally changing the point of recycling. because our technology is not only capital light, but can be completely scalable. So we can importantly scale down, not just up to the millions of tons you need for a smelter. This means we can integrate our technology into the upstream market. Therefore, we are recycling metals where they're most needed, right? So we're changing this point of recycling. We're coming at it with a decentralized model rather than a centralized model. Okay. And by recycling metals at the point of collection, we then create onshore, geosecure, circular supply chains. And that's really what we're driving at. You know, it's not just something that's going to make economic sense. There's a big strategic sense behind this as well.
Mm-hmm. And so if I was an interested party, like working with you guys, what does that, I guess, partnership kind of look like in getting your systems installed into my place?
Yeah, absolutely. So it depends on the type of partner you want to be, because there's that large fragmented market which plays in e-waste. Not everyone's going to build a DEScycle facility, you know, and we're actually launching under a joint venture model with our UK partner, Gap Group here. But then would plan to both license and roll out wholly owned plants in various markets. So if you are a small recycler who just wants to recycle in a more sustainable way, be paid quicker and be paid more, you know, I'm not going to commit to overpaying, but that's ultimately what we're trying to do, is to secure a feedstock. You know, you can just be a supplier to DEScycle, and rather than having to, you know, wait 6 months to be paid and ship your, you know, e-waste off to Japan or Sweden or wherever it might go, we'll be the local recycling company. So that's a big advantage. If you're a large recycling company that we could look to integrate our technology physically into your operation, all we need is a shed. So we can go onto almost any industrial site. We have a low power base. We don't need highly specialized, you know, chemical disposal mechanisms and infrastructure built in. So they can literally go almost on any industrial site. The only restriction then will be, let's say, size and scale of your shed. But, you know, we're talking like 40, 50,000 square foot, and that will house a operation that will do over $100 million in revenue from e-waste recycling.
Oh, wow. And with you guys like recently raising the 11 million pound in Series A funding, you guys are building like a demo plant in the UK. And so could you share more about what that demo plant looks like, what it's like, the size, all the way to kind of what the desired outcomes or expected outcomes would look like?
Yes, yeah. So incredibly excited about this. So right now we're building a demo plant in a place called Teesside in the north of England. This will be coming into operations early 26. And what we're doing here is proving the technology at commercial scale on commercial equipment for the first time. So to date, we've validated everything in a lab pilot, as we call it. So it's not small beakers, but, you know, still fits in the lab and lab equipment. So this is now using industrial equipment. So we're moving the technology from this kind of TRL6 pilot to a TRL7 demo. And that's very, very exciting for me as the commercial and business development lead, because that's the point where we start to trigger a lot of strategic traction. So everyone in the e-waste market has seen this before, heard the story before, and then the technology is not delivered. We're very confident we can deliver with this demo plant, and there is a lot of interest in the technology and in the business that we believe will be delivered against that.
For sure. And like I mentioned before, the funding part of making this all possible happened because of the Series A. And a lot of people are very curious about like, oh, like who's backing, like who, and so who is backing you guys at DEScycle, and why does that matter from your perspective?
Yeah, absolutely. So I've already mentioned our two major strategic investors of Cisco and Mitsubishi. Just a bit more on their partnership. So Cisco's investment really features around the supply side of hardware. So can we provide Cisco a solution that DEScycle can recycle the e-waste that they generate? Where Mitsubishi is completely on the other side. So they're really interested on off-taking the metals that DEScycle recycle. And those two strategic partnerships really dovetail quite nicely, helping to de-risk both sides of the business and the revenue model. In terms of our other key investors, so our Series A round was led by BGF, So they're one of the most active venture and growth investors here in the UK. What was really nice about VGF is they really understand deep tech. They're an evergreen fund, and they specialize in deep tech, or at least have a team that specializes in deep tech. So everything we've had with them has just been very supportive in terms of the challenges we're running into, what's actually needed to actually scale a deep tech business, rather than just a let's say short-sighted venture capital firm X who wants a return of 10x within 3 to 5 years, and nothing else matters. So that's been really helpful. Alongside BGF, and now I've got the chance to do the roll call. Vorburg Ventures, TSP Ventures, Green Angel Ventures, Cadmos Capital, Nesta. There's a large group of UK and US investors, and German, I should say, that have come in to back DEScycle. And having that quite broad spread geographically of interest has been another encouraging factor for us.
Oh, encouraging for sure. And you must have also shared like your vision for DEScycle in the next 5 years and beyond. And if you could share that with us, what exactly does that vision look like?
Yeah, absolutely. So the vision for DEScycle is to provide the new way of metals recycling. So completely change the industry from this centralized version of metals recovery to a decentralized one where we're creating local circular economies. We're producing these critical metals onshore in the countries that need them, both giving not only nations but corporates then power over their own metal supply.
Right.
In 5 years' time, we'll be scaling, we'll have proven this, and hopefully be rolling out operations in the UK, US, and Japan.
Neat. And I guess I have 2 more questions for you. For plant owners and facility owners, what do you want them to understand that they might miss at a first glance?
Yeah. So if we're talking e-waste recyclers, this is highly novel, what we're trying to do, but fundamentally we're going to solve your problem of not realizing enough value for the waste you currently collect and export. We're going to solve the headache of international export and shipment of e-waste, and we're also going to provide you a sustainable solution where you can then become a downstream recycler and producer of metals.
For sure. And the people who are looking to buy these metals after they're recycled, so someone like I believe it was Mitsubishi who's the partner for that. For these people who are interested in buying these recycled metals, in their case, what do you want them to understand that they might miss at a first glance?
Yeah, so a big thing here is we're not only economically competing, there's another kind of string to the DEScycle bow, and it's the traceability we can actually provide over the supply chain. So if you remember what I said back around smelting as a recycling route, they commingle feedstock. So you can have, chips from an iPhone all the way through to copper concentrate coming from the Congo, for example, going into the same plant. And how can you tell which metals which? You can't.
Right.
What we can do, because we're exclusively treating and recycling e-waste and we can scale down operations, is then we move from being able to say, a proportion of this metals recycled to actually fully tracing or physically tracing that metal through the system. Now, where it gets really interesting for someone like a Mitsubishi or a Cisco, we can take Cisco waste and then produce Cisco metal. Now, if we can provide that back into Cisco's own supply chain or Mitsubishi's supply chain, then all of a sudden that completely changes the model of buying resources on market. You can go to one of not just providing your consumers with a nice look, this Apple iPhone is made with 90% Apple metal, but you can actually enter a different model of how you purchase your actual equipment and natural resources. You can enter one into metal leasing almost.
Most definitely. And I think that ties back really well to kind of like my introduction to you guys, where it really does enable this circular economy concept. If you had a microphone to broadcast to everyone in the sustainability space to let them know what you guys are doing at DEScycle, what would you say?
Summing this up, e-waste isn't just a problem, it's the largest untapped resource base of critical metals. We lose $80 billion of this today. We've developed a proven scalable technology to unlock that value cleanly, locally, and securely.
Mm-hmm.
With our first plant launching in the UK, an expansion already building in the US and Japan, we see this as a generational opportunity to reshape how the world sources its metals.
I very much love it. The Earth definitely thanks you guys as well. And I really enjoyed the conversation here, Fred. Just want to say thank you for joining me today. And yeah, really appreciate you taking the time.
Yeah. Okay. Cheers, Sean. It's been great.
Thanks for tuning in. If you enjoyed this interview, follow along on EarthABC's LinkedIn to stay connected and never miss what's going on in climate tech. If you'd like to reach out or you're interested in coming on as a guest, feel free to connect with me, Sean Pack, on LinkedIn. We're always looking for inspiring ventures and founders in the climate space to feature on the show. Hope you enjoyed. Until next time.